Good day and welcome to another cubic function lesson with Mr. Simons. Today's lesson, we're doing corrections for number 1 to 3 of worksheet 1,15, which is foundation phase, and it revolves around instantaneous gradient. For exams, you understand this. It will be tested somehow, some way, and there's 2 to 3 marks available, right? Now, before we solve any problem, we need to understand what we're looking out for so that we know what we are solving. There, when I say before you touch the question, spot the clues, I specifically mean you must be able to identify a trigger, what thought it must bring, and what's the rule for solving that item. My apologies. So number 1, we say determine instantaneous gradient. This question can have the following words, or trigger words. Can use instantaneous gradient. Can also say gradient at a point. When I say rate of change at a point, I'm also referring to instantaneous gradient. I can say find f prime 2, meaning substitute 2 in the first derivative. Determine the slope, which is also gradient. And the gradient when x equal to 3, differentiate. So all these specific words refer back to the same procedure. So immediate thought, when you hear instantaneous gradient, etc., we must be able to differentiate first. Right? An instantaneous gradient always comes from the first derivative and not the original equation. Right? This question can also be restructured. Determine the gradient of a tangent. So trigger word, gradient of a tangent. Tangent to the curve, slope of a tangent, equation of a tangent, find the tangent gradient, gradient the point of contact. So again, tangent means find the derivative, and we should know the gradient also comes from the first derivative. Actually done, I think in 1.1.4's worksheet, I've done some where I showed you how we get the gradient without asking for it. Alright, so let's look at problem number 1. Alright, number 1, find the instantaneous gradient. So when you see instantaneous gradient, we will be required to find first derivative of the function f of x equal to 2x cubed minus 3x squared minus 11x plus 6 at the point where x equal to 2. So technically what we are saying to you is equation given there, because of instantaneous gradient, I must find the first derivative. In the first derivative, I have to substitute the value 2. Right? So, equations given to find the first derivative, f prime x. When I say exponent times the coefficient, so 3 times 2 gives me 6. Then we always subtract 1 from the coefficient. 3 minus 1 gives me 2. There, exponent times coefficient, 2 times minus 3 gives me negative 6. 2 minus 1 gives me 1. There, 1 times negative 11 gives me negative 11, and 1 minus 1 becomes 0, so x to the power 0 becomes 1, falls away. The first derivative of a constant is always 0. Because they've given me the point, I have to substitute it in x equal to 2. So there, if I substitute 2 in, x becomes 2 squared. Minus 6 times 2 minus 11. 2 squared is 4 times 6 is 24. 2 times negative 6 gives me negative 12. Minus 11, so this gives me 24 minus 23, which is 1. So my instantaneous gradient, or my gradient of my tangent, would be 1 at the point x equal 2. Now take note how we give you a mark. 1 mark for finding first derivative. Second mark for substituting the point in. The third mark for getting the correct answer, 1. Right? So very important, as I say, stop losing marks. Understand where we allocate marks and which of those you can get. As you are practicing through these questions, see how much of the 3 marks you are able to get. Every mark you get brings you closer to the target you have set for yourself. Number 2, find the instantaneous gradient of the function f of x equal negative x cubed minus x squared plus 16x plus 16 at the point where x equal minus 1. So when I see the word instantaneous gradient, I should know I'm first finding first derivative, right? Then in the first derivative, to get that gradient, I'm going to substitute the value minus 1. So there's my equation given. From there, to find the first derivative, f prime x, 3 times minus 1 gives me negative 3. 3 minus 1 gives me 2. 2 times the negative 1 gives me negative 2. 2 minus 1 then gives me 1. 1 times 16 gives me 16. And there my first derivative done. Remember, first derivative of constant, 0. At which point where x equal minus 1, so minus 1 gets substituted into the first derivative. So there x squared becomes minus 1 squared. Minus 2x becomes minus 2 minus 1 plus 16. So negative 1 squared is positive 1 times negative 3 stays negative 3. Negative 1 times negative 2 gives me positive 2 plus 16. So 16 plus 2 is 18 minus 3 gives me 15. So my gradient of my tangent equal 15 at the point where x equal minus 1. Again, 1 mark for finding the first derivative, 1 mark for substitution. Right? So that first 2 marks, I believe with sufficient practice, you all can get that marks. And then 1 mark for the correct answer. Alright? No calculation, sometimes you'll make simple errors, even on a calculator. But yeah, should be able to get all 3 marks. Let's look at number 3. Find the instantaneous gradient of the function given fx is 2x cubed plus 7x squared minus 17x minus 10 at the point where x equal to 1. So again, just to refresh, see the word instantaneous gradient, I'm finding first derivative, right? Then I must substitute the value 1 into the first derivative. So first derivative, f prime x, means I'm going to multiply the exponents with a coefficient and subtract 1 from those coefficients. So 3 times 2 would give me 6. 3 minus 1 would give me 2. 2 times 7 gives me 14. 2 minus 1 would give me 1. 1 times negative 17 gives me negative 17. And the first derivative of a constant is 0. Then in that first derivative, I'm substituting 1. So that becomes 1 squared. 1, so 1 squared is 1 times 6 gives me 6. 14 times 1 would give me 14 minus 17. Right, that gives me 20 minus 17, which is 3. So my gradient of my tangent at point x equal to 1 equal 3. Right, so I hope you understand, I hope you practice, so I get used to what the English is saying and what procedure you have to follow. Right, in the next video, I'm going to be looking at the same question, but the English has changed, different variation, and this is what we do with you in exam, trying to catch you out. God bless. Bye.